So, how do we actually do MBSE? What exactly do we need to know to get started? Simply said, we need to wrap our head around just three main things: a modeling language, a modeling method, and a modeling tool. We like to call these the three pillars of MBSE. When we're working on a design team to build and integrated models, these three pillars work together perfectly. Basically, we'll use our dedicated software tool to follow a specific set of steps, that's our method, which helps us build our digital model using a standardized visual language. Now, if we just learn the language on its own, we're already off to a great start. Knowing the language alone lets us sketch out our system design ideas on a whiteboard or a piece of paper so we can quickly and clearly share our thoughts with our team. Because it's so foundational, learning that language is the very first skill we should pick up, and it's actually the main focus of what we'll be covering. But remember, to practice true MBSE and get that big return on investment we talked about earlier, we'll eventually need to possess all three of these skills. So let's break them down and examine each pillar in a little more detail. When we sit down to create one of these digital models, we're actually speaking a language. Now, I'm not talking about the everyday language we learned growing up or the words I'm using to talk to we right now. Instead, we're using what we call a modeling language. Think of it as a specialized rule book. It tells us exactly what kinds of pieces we're allowed to put into our model, how we can connect them, and if it's a visual language, exactly what symbols and shapes we're allowed to draw on our diagrams. In the world of MBSE, we usually rely on a specific visual language called SysML. To be exact, we often use version 1.7, which is a highly refined standard that lets us clearly map out a system's structure, its behavior, and all of its strict requirements. SysML is the main focus for systems engineers, but it isn't the only game in town. Depending on what we're building, others might use totally different visual languages like UML or BPMN, or even entirely text-based languages. It just depends on what makes the most sense for the specific project. At the end of the day, the biggest takeaway is that every single one of these modeling languages serves as a standardized way to communicate. Because everyone is following the exact same set of strict rules, there is absolutely zero confusion about what a model means. And being able to clearly build and read these models, well, that is the very heartbeat of the entire MBSE approach. Now that we've got the language down, it's important to realize that learning a modeling language is really just the first step on our MBSE journey. Think of the language like a basic grammar rule book. It tells us if our model is put together correctly or if it's totally broken. But here's the catch. Those rules don't actually tell us how or when to use the language to build our model. They stop completely short of giving us an actual strategy. That is exactly where our second pillar, a modeling method, comes into play. If the language is our rule book, the method is our roadmap. It's a clear, documented set of step-by-step design tasks that guides our team on how to actually create the system model from scratch. More importantly, having this roadmap makes sure that every single person on the team is building things consistently and heading toward the exact same finish line. Without that clear guidance, we'd have team members going off in completely different directions. Everyone would build their piece of the model with totally different levels of detail, depth, and quality, which would quickly turn our perfect digital blueprint into a confusing mess. Once our team has nailed down exactly why we're building the model, we're ready to tackle a whole new set of questions to guide our work. For starters, we'll need to figure out the big picture. How much of the outside world, the environment surrounding our system, do we actually need to include in our model? Then, once we've figured out the outside, we have to look inward. We'll need to ask ourselves, which specific pieces of the system itself actually need to be mapped out? Once we've figured out the physical pieces, we've got to think about the action. We'll need to ask, what exactly does this system need to do? And which of those behaviors actually need to be mapped out in the model? From there, we have to figure out how far down the rabbit hole we want to go. Just how deeply do we really need to break down all those inner workings and actions? And finally, we have to draw a line in the sand. It's crucial to decide which specific details absolutely must be in our blueprint and which ones we can safely leave out for the development team to figure out when we're actually building the thing. By figuring out all those details, we're officially defining the scope of our project, which basically sets the goalposts for our entire team. Having that clear finish line is super important because it's the only way we'll actually know when our model is officially complete. Now, before we think complete means we never have to touch it again, let me clear something up. Our team is definitely still going to tweak and evolve that model over time as rules change or new design choices are made. So, what do we actually mean when we say it's done? In this discussion, being complete simply means our models meet the requirements we originally laid out in our project plan. Once we've nailed down that scope, it actually dictates the next big step: choosing the specific modeling method our team is going to follow. Now, we don't necessarily have to reinvent the wheel here. There are plenty of well-documented methods out there already. I'll show you shortly. Our team can easily just pick an existing one and tweak it to perfectly fit our exact goals and needs. But if none of those standard options feel quite right, we always have the freedom to build a completely custom method from scratch. We won't be diving into the nitty-gritty of how to do that in this particular video, but it's great to know we have that flexibility. Now, it's important to clarify that our main goal here is to get we super comfortable using SysML, the actual modeling language. We aren't here to force any specific modeling method on us. And that is really the beauty of SysML. It's completely flexible. We can use this language to build our system model regardless of which specific method we decide works best for our team. But don't worry, I won't leave you totally in the dark on the method side of things. I'm still going to take a little time in this video to point out some of the most popular modeling methods out there, and I'll even provide some great resources you can check out to help guide you along the way. Now, keep in mind that these well-known methods are huge and cover just about every stage of a project's lifecycle. Because of that, not every single step they recommend is going to make sense for what we're building. We absolutely need to tailor and tweak whichever method we pick so it perfectly fits our project's unique needs. At the end of the day, think of these existing methods simply as really solid starting points to get our team moving in the right direction. All right, so we've covered the language and the method. That brings us to our third and final pillar of MBSE, getting really good at using a modeling tool. Now, you might be thinking, can't I just use any standard drawing app for this? Well, not exactly. Modeling tools are actually a very special, heavy-duty class of software. What makes them so special? They are specifically built from the ground up to understand and enforce all the strict rules of modeling languages, like the SysML language we talked about earlier. And because they know all those rules inside and out, they act like a smart assistant. They actually help ensure that you are building totally accurate, well-formed digital models every single time without accidentally breaking the system. Now, I need to make a really important distinction here. These specialized modeling tools are completely different from your everyday diagramming apps like Visio, SmartDraw, or Process On. Why are they so different? Well, it all comes down to what is happening behind the scenes. When we use a standard diagramming tool, we're really just drawing flat shapes on a blank page. There isn't any smart data or an underlying system connecting those shapes together to make sure everything stays accurate and consistent. If we change a name on page 1, we have to remember to change it on page 10. But with a true modeling tool, we are building something much deeper. Instead of just drawing pictures, you're actually creating a smart, interconnected web of parts and relationships. And those diagrams we end up looking at, they're really just a visual window or a quick snapshot into that powerful underlying model. So here's where the real magic happens. When we tweak or change a piece on our diagram using a proper modeling tool, we aren't just erasing a line on a screen. We're actually updating that exact piece deep within the underlying model itself. And because everything is connected, the software instantly goes to work. It automatically updates every single other diagram where that part shows up, all in the blink of an eye. It is an incredibly powerful feature that saves a ton of time and prevents countless headaches. And it's a superpower we'll only find in this specific advanced class of tools. One really important thing to keep in mind is that a modeling language like SysML doesn't belong to any single company. It's totally vendor neutral. Instead, different software companies take that standard rulebook and build their own specific programs around it. Because of this open standard, we're going to find a whole bunch of modeling tools out there created by different commercial brands and even nonprofit groups. And just like buying a car, these tools vary a lot. They come with different price tags, offer different bells and whistles, and honestly, some follow the strict rules of the modeling language a bit better than others. So, what does this mean for us and our team? It means that picking the right tool for the job shouldn't be an afterthought. Taking the time to figure out which software best fits your project's specific needs, and of course your budget, is an absolute must when you're first making the leap into the world of MBSE. Now, just like the open standards of the modeling languages we just talked about, I want to be completely upfront with you. I am totally vendor neutral. I'm not here to push one specific product or hawk a particular software in this video. But since your team is inevitably going to have to do some research and pick the best software for your specific needs, I want to give you a head start. I've put together a quick list of some top-tier SysML compliant tools you can look into. Just a quick heads up before we dive in though, these are all commercial grade tools, which is really just an industry euphemism for they are not free. To kick things off, you might want to look into Visual Paradigm, made by the company of the exact same name. If that doesn't seem like the right fit, another solid option to explore is the PTC Windchill Modeler. From there, you could also research Enterprise Architect, which is created by Spark Systems. Next up on the list is Cameo Systems Modeler, which is also known as Cadia Magic by Dassault Systems. Moving right along, if you are looking for something from a massive tech brand, IBM has their own offering called Engineering Systems Design Rhapsody. And finally, wrapping up our list, you could take a look at UModel, developed by Altova. Again, these are all just great starting points to help you and your organization kick off your research. Now, if you're on a tight budget or just want to experiment before diving in, don't worry. There are also some fantastic free modeling tools out there that run on open source licenses. For example, you could check out Modelio, which is created by ModelioSoft. Another really popular free option is Eclipse Papyrus, brought to you by the Eclipse Foundation. Of course, whether you're looking at the expensive commercial options or the free ones, there are a ton of different factors you'll need to weigh when picking the perfect software. But if I can give you one massive piece of advice, it is this. Whatever you choose, strongly consider making sure the tool is XMI compliant. Now, XMI stands for XML Metadata Interchange, but all you really need to know is that it is a special standard that lets different modeling tools actually talk to each other and swap data. And why is that such a big deal? Because it totally saves you and your team from falling into the vendor lock-in trap. If you pick an XMI compliant tool today, you are guaranteeing that if your project's needs or your budget ever change down the road, you can easily pack up all your hard work and move it to a totally different software program without having to start from scratch. Let's do a quick recap of everything we just covered about the incredible world of model-based systems engineering, or MBSE for short. If there is one thing you take away from this video, it's that building complex things like spacecraft or smart grids doesn't have to be a scattered paper-pushing nightmare. For years, teams were stuck using the old document-based approach, manually typing up mountains of separate files, spreadsheets, and charts. When one little design detail changed, some poor engineer had to go on a massive scavenger hunt to manually update dozens of disconnected files. It was wildly expensive, incredibly frustrating, and practically guaranteed to cause snowballing errors. But MBSE completely flips the script. Instead of juggling endless documents, teams now build a single brilliant digital blueprint, a central system model. This model becomes the ultimate single source of truth. If you need to change a part's name or tweak a requirement, you just update it once in the model, and the software instantly ripples that change out to every single diagram and document. It is an absolute game changer that prevents mistakes before they happen. To actually make this magic work, we learned that you need to master the three pillars of MBSE. First up is the language. You need a standardized visual language like SysML so everyone understands exactly what the model means. Think of it as the shared grammar rulebook for your blueprint. Once everyone is speaking the same language, you need the method. This is your clear step-by-step roadmap that ensures your entire team is building the model consistently and pulling in the exact same direction. And finally, to bring it all to life, you need the tool. You can't just use a basic drawing app here. You need heavy-hitting, specialized modeling software that actually understands those language rules and automatically connects all your data together behind the scenes. When you put those three pillars together, you stop just drawing pictures and start engineering the future. If you like this video and want to learn more about how to master the art of systems engineering, please hit that subscribe button down below and follow me at Mad Badger Engineering for more content right here on YouTube. Thanks for watching, and I'll catch you in the next one.